Okay, this next one's a fun one. So we've got a couple of things to consider here. So we've got the integral of e to the x over 1 plus e to the power of 2x. Now, what do we want to choose as our u in this case? Remember, we're going to need to choose a u that allows us to get rid of the rest of the x components. So we're going to have to get our u, and it's going to have to give us a good du. Also, we're going to have to make sure that we're left with an integral that we actually know how to integrate here. Well, we've got, maybe we chose 1 plus e to the 2x. If we took the derivative of this, our du would end up being, what, 2e to the 2x? Now the problem with this is that we don't have an e to the 2x up here. We have an e to the x. So that automatically becomes a problem. So that's not going to work out for us. Now the trick to this one, and it is kind of a trick, but it hopefully is a trick that will build intuition next time, is for us to recognize that we could rewrite this integral as the integral of e to the x over 1 plus. Now how could we rewrite e to the 2x? There's another way that we can write that. Remember, when we multiply exponents, this is similar to us raising exponents to exponents. So we could write this as e to the x quantity squared dx. So now we've just got e to the x's. If we were to let u be e to the x, our du would just be e to the x dx. So we definitely have all the pieces to do a substitution. Here we just have to be careful in terms of where do we put our u's and what do we pull out as our du. Now I'm going to once again kind of rewrite this to hopefully make it clear how this is set up. This dx is not in the denominator. We could think of this e to the x dx as being up top, and then we've got 1 plus e to the x squared down in the bottom. So hopefully that makes it a little bit more clear. Maybe if it's not, we could write it like this. We could think of this as 1 over 1 plus e to the x squared times e to the x dx. All equivalent ways of us rewriting this integral. I think if we were to look at this particular version, it makes sense how we'd perform our substitutions now. So we're going to let that e to the x dx be our du, and then this e to the x down here, that will end up being our u. Let's see what we're left with if we do that. So now we've got the integral of 1 over 1 plus u squared, and then we've just got our du. So do we know how to integrate this? We now have everything in terms of u, but do we know how to integrate this? And what we have to remember, and this might be one that you didn't use as much in Calculus 1, but you're going to see popping up in Calc 2 and beyond over and over again, is this is the integral, or the antiderivative formula for the arctangent, or the inverse tangent. So this formula results with the inverse tangent of u plus c. Or some of you may be used to writing it as the arctan of u plus c. I'm fine with either one of these. And then lastly, we just need to make sure that we substitute back in for u, and we have the inverse tangent of e to the x plus c. So sometimes these substitution problems can get tricky, and you have to, maybe it helps to have your antiderivative formula sheet sitting there with you while you're working through these problems in homework, so that you know what to recognize as something that you can actually integrate. And I think that becomes very clear in this next one as a helpful tool.